So today we're just going to be writing some code. I'm not going to add any files or do anything like that. We're just going to be going over a new thing in Tone.js, which is creating a sequencer. So in the previous lessons, we've learned how to make synths and samplers and trigger sounds through those objects. And today we're going to use a different component of Tone, which is the sequencer, which is used to schedule different, sounds or synthesizers or whatever we want to use so that we can actually build a composition with rhythm and melody and harmony and all the things that make a song into a song. So we'll look over some of the basics for those, and I'm going to start with a new replet today. So we'll kind of go over a few things from the very beginning as well. That's always good to review. So I'm going to go to my replet page and just create a new replet. And I'm going to use an HTML, CSS, JS template as usual. And I'm going to call this Tone Sequencer and create my replet. And I don't have anything in here right now. So I'm going to add the Tone library and the P5 library again. I'm not going to use P5 for a lot in this example, but it will be useful to add some events instead of having to write those in native JavaScript. And we can also visualize what's happening in the sequence using P5, so that'll kind of simplify things a little bit. Um, so I'm just going to delete most of the HTML. I don't really need this. And I'm going to change the title of this to Tone Sequencer. And then we just have to get some references to our script. So let's grab the Tone script. I think if we go to Tone.js, we can find the link for this. Um, Actually, I think it's on the Tone GitHub. And I'll put links to all of this stuff in the video description. Let's see. I think it has an example somewhere down here. Maybe it's in the wiki. Installation. Okay. I think, huh, no, it's not in here. I forget where this came from. I'd have to review my old video. I think it's in let's see, Tone CDN okay. So CDNs are usually places where you can find the library being hosted. Here's one that is hosting a recent version of Tone. I think this is the right one, but I think there was a better one. I'm just gonna look at my old project real quick and see where I got it from. Sorry about that. Let's go to Tone plus P5 and go to the HTML. Okay, this is what I thought it was, unpackage.com/tone. So where does this come from? I don't remember how I got this. Let's Google it. Oh, I guess it must have just been in one of the examples. Anyway, let's just copy this over. So we have this is the Tone script that we can add into our project. And then the P5 one is right here, up here. I think this is also from the P5 GitHub. But since we already opened this up, let's go ahead and copy that P5 script over. So we have our Tone script, and now we have our P5 script. And I'll put links to these in the video description. And then we have to actually add a link to our own script. So let's add a new script tag, say source.script slash, sorry, source gets quotations script.js, and then just close this script tag. And I think that's all we need for our HTML. So let's go back to script.js and we'll get started here. So I normally like to start with a multi-line comment just so we know where we are. So this is a tone sequencer example. And we're going to be using one of the sequencers in Tone. I'm going to put a link to it here so we have reference to it. So I'm going to go back to the main Tone website and go to their API. And so what we're using now, there's a couple of new components that we're going to use. So far we've really only used instruments like the synths, and we use the player, and we use some effects, and that's pretty much it. But today we're going to look at the transport, which is the component of Tone that does scheduling and timing. And so it kind of like counts for us and keeps track of time. And so we're going to be looking at that a little bit. And then we're also going to be using a loop. So under the events section, there's a bunch of different types of events in Tone. Loop is kind of like the most simple one. So you can see this example here is very simple. It's not even going to play music, but if we run this example, you can see it just logs the time. So this is a time measured in milliseconds, and this loop is just playing, it's just triggering every eighth note. And so this one is very, very simple. It doesn't require any other inputs. And so we can use this to do a lot of different types of things. There are a couple,
Hold on.
yeah, go ahead.
Uh, we can't hear the loop
There's
if we're
no,
supposed to hear
yeah, there's no audio in that one. So
it. No.
all it's doing is logging the time here. So you can see actually it has the printout right here. But yeah, the loop actually doesn't play audio, it just sequences an event. So it's kind of the simplest one that we can use, and then we can use our own code to change the sequence, which is what we'll look at how to do. There's other more complex ones like the pattern one. This will actually play notes in an order. This code doesn't have anything that will actually play the notes. It's just an example, but we can also see the sequence one, which works in a similar way, but it's a little bit more complicated. If we So you can see a sequence. It's similar to a pattern, but it lets you play different notes. But we're going to skip these because we don't really want Tone to keep track of our notes for us. We want to be able to have control over what notes we're playing and write our own code to trigger the notes. And so this loop event is very, very simple. We just create a loop and it just calls a function every eighth note or quarter note or whatever note we specify. And then we just use tone.transport to start the loop. So this is all the loop code that we're going to use. We're also going to use the transport, which has some uh, different parameters that we are going to be able to use, like the start and stop. Will let us know if the transport is running. Um, and we can also set the beats per minute, the BPM, or the speed of the loop. So we'll use the transport along with the loop in our example. So I'm going to put a link to these parts of the documentation into our comment here. Let me turn the font size larger. So here's our transport documentation, and here's our loop documentation, just so we'll have access to those. And now we can get started setting up our project. So we are going to start with some global variables. And so there's a few things that we're going to need in multiple places in this project. We're going to need a synthesizer. So I'm just going to use kind of a default FM synth. But we're going to have to create it in our setup function and then use it inside of our loop. So I'm going to declare the synth, but we won't set it to anything just yet. We're also going to need a reference to our loop. Uh, we can, well, actually, we might not need a reference to our loop. Let's come back to that. So we definitely need our synth. Um, oh, we do need a reference to our loop. So we're going to get a reference to our loop as well. I'm going to call this tone loop. The reason I'm calling it tone loop and not just loop is because loop has a definition already in P5, and so it'll create a conflict with the P5 library. So we have our synth, we have our loop, and I think we can get started. We'll have to come back here to add more to this in a bit, but for now we've got some global values. And so since we're using P5, we can use our setup function. And we're not loading any media, so I'm going to skip the preload function. If I was loading samples or other media like images, I would probably put a preload function in here, but I'm not doing that, so let's skip ahead to the setup function. So since we're using P5, let's go ahead and create a canvas for us to look at and print stuff on. So we'll create a canvas, and I'm just going to use window width and window height as the size of the canvas. So it'll just fill up the available space. We're not going to put a lot of HTML on this one or interactive components because we're just going to have the user just click on the canvas and make that trigger our loop. So once we've created our canvas, let's set up our synth. So for our synth, I'm just going to use a default FM synth. There's a bunch of other synths, so you could choose something else for this, but I tend to like the FM synth the best. And so here's our FM synth, pretty simple. So let's just grab that code, and then I'll switch it to my synth. So I'll just replace this with my synth variable. So synth is going to be new tone.fm synth, and we're going to connect this to our speakers to destination. And then we're going to create our tone loop. So this is the loop that's actually going to do most of the work in this example. So let's say tone loop, and let's go back to our loop code down here. And so it looks pretty similar to other things that we've used, but we're not going to write it exactly the way this is written. Instead of doing a callback function inside of our parameters, like we see here, I'm going to make a different function so that it looks a little bit cleaner. And we don't need to start it right away, so we're going to get rid of that as well. But we are going to choose the duration of our loop. So we'll start with that. So we're going to say new tone.loop. And so then the first parameter is the callback function. You can see this is using an arrow function, which a lot of the tone examples use. I don't think we've talked about that in this class, but basically an arrow function, this arrow replaces the word function here. And so it's really exactly the same thing as if you wrote it like this, but for various reasons, people like the arrow function syntax. But what I'm going to do is actually just create a new function. So I'm going to say play loop here, and I'll just define that function in a little bit. So then we just need the duration of our sequencer. So this is how often it plays. And for people who are like basically familiar with music, you probably know what a quarter note is or an eighth note is. For those of you who are not, generally, I think we talked about this a little bit before, but let's just look at a. We can look at some drum notation as Gal has suggested in the past, because this will be a little bit easier to understand. So in most music notation, most music is written in 4/4 um, rhythm. Not all of it is, but we don't really need to get into that right now. But in most music notation, we represent one bar is one whole note. So it's like it's one uh, sort of duration of our sequence, and we can divide that bar. So one of these guys is called a bar. We can divide that into different numbers. So, these notes with one line are called quarter notes. So there are four notes in the bar. So we call that quarter notes. And we'll start with that. If we had eighth notes, then we'd have eight notes in one bar. You can also have a combination of like, one whole note. You could have two half notes. You could have a half note and two quarter notes, etc. So when I say here for n, what I'm saying is a quarter note. And we'll hear the difference between that once we get our loop started. Okay, so next, let's make our play loop function. So this is going to play each instance of our loop. And all that's really going to happen in here is that we're just going to play our synthesizer. So let's go ahead and set that up. Let's say synth dot trigger attack release. This is kind of the most basic way to play our synth. Let's stick a note in there for now, just a hard-coded note that we'll change later. And then I'm gonna add in, I'm gonna make this an eighth note. So the eighth note here is the duration that we're going to play the synth for, and I want to make it less than our loop because we'll be able to hear the difference much better if this note ends before we play the next note. And I'll show an example of that in a second. So for the moment, this is actually all we need to do with our play loop function. It's just going to trigger one note from our synthesizer. So then we have to set things up so that our user can actually start the synth. So I'm going to say function mouse pressed. So I'm just going to give them one very simple interaction to get things started. So when we press the mouse, what we're going to do first is start the transport. So I'm going to say tone.transport.start. And so that'll start the transport, which is the main component in Tone that's going to count time for me. And once that's started, I can also start my loop. So I'm just going to say tone loop.start. And that should actually get us started. Let's draw something on the canvas just so we know where it is. So let's say function draw. And let's just draw a background so we'll be able to find the canvas. So let's just draw a light blue background. Okay, so I'm running the code now and I'm getting nothing. So let's check my console. Let's run it again.
You didn't call the functions.
That's true, but I have P5 in here, so P5 should call the functions for me. I think I must be missing something. Let's see. Huh, I'm getting like a weird go to replit. Okay, I think I'm just having a connection issue. Let's try opening this in another page. Hmm, that's weird. I'm still streaming, so it's not an issue with my internet. Maybe an issue with Replit. Um, huh, that's weird. Okay, let's just try closing out Replit and opening it again. Oh dear. Yeah, it looks like Replit is having some issues. I really am not uh, very lucky with these services this semester. Huh. Let's see if one of my other Replits works. Make sure it's not an issue with this specific one. Oh boy. Yeah, it looks like the whole thing is down. Okay, well, we can write a little bit more code while we're waiting for it to come up. And if it doesn't work, we could potentially switch to a different editor, maybe go over to P5.
My
Um,
replit works fine.
yours
Oh
works?
wait, no,
No.
just now it doesn't
Okay.
work.
Well, that's what happens when we're working on the internet. So let's give it a minute. So I'm just going to write a little bit more code and then we'll try and see if it works again. So let's close these, go back to Replit. Let's see. Looks a little bit more promising. No, it's still. Okay. So what else can we do? Did the draw function. Started our loop. Hmm. Yeah, we might have to like move to P5 or something. Okay. Yeah, let's just copy this over to P5. If this works again later, we can come back, but I'm gonna go to P5. assume that most of you guys have
That's
seen
not,
what?
if it's a computer, can I set the BPM to something that's not humanly possible?
Yes.
Is that possible? Yeah.
Yeah. Uh, yeah. Yeah. We'll play with the BPM in a minute. Um, okay. So I'm sure you guys have seen the P5 editor before. It seems to be running. So let's just use this for now, and we'll go back to Replit if it starts working again at some point. Um, but I'm just going to copy the code over from here. P5 already obviously has P5 built into it, so let's just put tone in there. One thing that I do have to change that I'll show you guys is that P5 has its own sound library, and a default P5 project actually has a link to that sound library, but this will actually conflict with tone because they'll both be fighting for the audio context. So if we want to use tone with P5, we need to get rid of this and just let's get a link to tone that we were using before, and let's put this here. So that will stop any issues with that. And so then we can go back to Sketch.js, and I'm just going to copy my code from here directly into here, and let's see if it runs. There we go. Okay, so it works over here. So we'll keep working from this P5 sketch for now. And if Replit comes back on, we'll use that later. If not, we'll just stay over here. Um, s-
It's back on.
oh, it's great.
Themes.
Uh, yeah, I'm sure as soon as I actually, there we go. Okay, so as soon as I got over to P5, Replit turns back on. So I'll leave this here. If it crashes again, we'll come back. But for now, we can stick with Replit. Anyway, so you can see that it's running now. So if I run this sketch and I click on the canvas anywhere, we start to hear that synth being triggered every quarter note. Okay, so let's first build something that will let us turn the synth on and off because it is pretty annoying to listen to if if especially if it's just playing the same note over and over again. So we can build in some logic that will turn the synth on and off depending on the state of the synthesizer. So let's build that now before we do more examples. So I'm going to go to my mouse press function, and what I'm going to say is I don't want to start the transport unless the transport is not currently playing. And there's a way that I can check for that. I can say if tone.transport.state. And so the state of the transport saves whatever current state it's in. And so if the state is stopped, that means that the transport's not playing. And so if that's the case, then we can start the transport and start our loop. And if it's something else, we can say, else, or let's just do another if. Actually, we probably need an else if here because we don't want to go back and forth. So if else if tone.transport.state equals, what is, I forget let's go back to our transport. I think it's started, let's see, state, started, stopped, or paused. Okay. So if it's stopped, we'll start it. And if it's started, meaning it's playing, then we'll stop it. So we'll just take both of these lines of code and paste them in again and just change these to stop. So we'll stop our loop and we'll stop our general transport. So now we can just click to toggle it on and off. Okay, so now we can play around with things a little bit more. So uh, we can notice what happens if I change this quarter note here. So this is the main loop, and the quarter note here determines what the sort of default note of the loop is. So if I change that to an eighth note, it's going to go at an eighth note. It's going to play every eighth note. And notice it's hard to hear that because we're just playing the same note over and over again. So we can make our synth note smaller. We can do a 16th note. So now we can see, the relationship between this note, which is our loop, and then the note that we play here. So let's go back for a second and then play with the BPM as well. So we can say tone.transport.bpm.value. So we have to say all this crap just to set the BPM value. And the BPM is beats per minute. That's roughly how fast it's playing. And so a lot of music is like around 120 beats per minute. So that's half a beat. That's a beat for every half second. And so that's like where a lot of music will kind of generally be around. If you have like a slower song, like a ballad or a waltz or something like that, it may be a slower BPM, like maybe 80 or around 100. If you have like a really fast pop song, that might be more like 140 or something like that. But our default is 120. So let's see what it sounds like if we slow it down quite a bit. Let's do our BPM is 80. So you can see it's much slower. If we do a BPM of 160, we can see how that sounds. It's faster.
Do 250.
Okay, we can try 250. It may be, I wonder if it has like a
250. This is the highest the metronome can go. It won't go over 250. But the question is if you can go like 600 if it actually works. Because I don't think anybody can play more than like 400. I think is the highest anyone can play.
Yeah, so I suspect that Tone probably does something to constrain the BPM to something reasonable. Because if you set it to like a million or something like that, it's gonna do, I don't know what that would do, but it probably would be too much for the computer. But let's see. So if we set it to 250, it says it's 250, so presumably that works, but that doesn't really sound like 250 to me. Let's go back to the default and see what that sounds like.
I have a question, Professor.
Yeah.
If we make the BPM negative, does the music play backwards?
I don't think so, but let's try it. But let's first, so Gal wants to make it really high. So let's try like 600 and see what happens. And then we'll try negative. Okay, so you can, so it does go to 600. It's really fast. Let's try
Yeah,
600.
I heard somebody play faster than that.
Yeah,
Oh, that's humanly impossible. That's
yeah.
impossible to do.
So 1200, it's still going. Let's try 2000. So at a certain point, it's just going to start to sound like, I don't even know what it'll start to sound like. Let's try 20,000. So it's kind of interesting actually, but it just kind of sounds like um, kind of glitchy, like it's starting to stick together. So let's try negative. It's probably not going to play backwards, but it'd be interesting to see. Um,
It's probably set to an absolute value.
well, it didn't
That's
print
why.
it didn't print out the value, which is kind of interesting. So I set it to negative 120, and then I'm printing the value here, but it doesn't come out. So that is actually kind of interesting. That's not really what I would have expected. So if it says 120 here, let's see if I set it to 0. It's 0. If I set it to negative 1. So it's doing something. I don't know what it's actually doing, but it still sounds like it's just 120. Um, so anyway, we can change the BPM. You guys can play around with that to try different things. I'm gonna set the BPM back to 120, just the default, but we can change it later if we want to. Um, So what do we want to do next? Next, we want to change our notes that we're playing, right? So right now we're just playing one note, so it doesn't really sound very interesting. So what we want to do instead is play a sequence. And so here is where we're going to use our own code to do what Tone does with some of the other things like the pattern or the sequence, but it's not very hard code to write, and it gives us a lot more options in terms of expanding how we use it in the future. So what I'm going to do is just make a new global variable to contain my sequence. And I'm going to use a special type of data for this called an array. So I'm going to say let sequence equal. And when I want to make an array, I use square brackets. Um, so this is an array. An array is like a list, uh, and it's just a list of data. So it could be numbers, it could be values. In this case, we're going to make some notes. Um, and so when we add notes to our sequence, we can just choose a MIDI note. I'm going to start with MIDI notes. We'll do some other stuff later. So I'm just going to do a C major arpeggio. So an arpeggio is just a sequence that includes the main note of a scale, the third, the fifth, and the octave. So for my arpeggio, I'm going to say C4. The third of C4 is E4, and the fifth is G4, and the octave is C5. And you'll see what this sounds like. This is just an easy way to make four notes that sound nice together. We'll look at better ways to create these types of sequences in a minute. Um, but the next thing we do need to do is keep track of where we are in our sequence. So we need something called an index. So our index is going to start at 0, and the index is just going to follow along our sequence. So an index is used to count. And so when it's 0, we start counting an array at 0. So when it's 0, it'll be C4. And then when it's 1, it'll be E4 and G4 and C5. So we use an index to get the value out of an array or list of values. So now instead of just playing C4, when we arrive at our loop, we can figure out what note to play in our sequence using the index. So I'm going to say before I trigger a note, I'm going to create a variable called note. So I'll say constant note. And I'm making it constant because it's only going to exist for a second before we play this note. And then we're going to go to the next one. So we don't need to change this later. And so my note is my sequence, my list of notes at the index that I currently want to play. And so then I can just replace C4 with my note. And when I run it this way, we haven't quite finished yet. Notice when I run it this way, it's just going to continue to play C4 again. So here's where using an array is useful. I can change this index, and that will move me to the next note in the array. So I can say index plus plus. This is a shorthand for index equals index plus 1. So we're taking the value of the index, which is 0. We're adding 1 to it, which gives us 1. And then we're assigning that back to the variable index. So now the variable is 1. So when we come back around to our loop, sequence at index will be 1 instead of 0. And so we'll get E4 instead of C4. And then we're going to keep going. So let's try this one. Okay, so that sounds cool, but notice it doesn't go back to the beginning. If we want to have a sequencer, we need to, loop our sequence. So how do we do that? We just test to see if we've reached the end of our sequence. So we're going to say if index equals sequence.length, then we set it back to 0. So there's some more kind of sophisticated mathy ways to write this that you'll see in a lot of examples, but this is the most kind of explicit way to say what we're doing. So at the end of sequence, oh, and I didn't I didn't press pause, and it's trying to play a note. You can hear a little tiny sound. But anyway, at the end of sequence, start over at 0. So now we'll hear the sequence loop. So now you can maybe start to see how we can create some real music with this. So that's kind of fun.
So
Yeah.
What if I want to have a stop between a note? Like if I want a quarter note stop between C4 and E4.
Like a rest.
Yes.
You could do that. We could just put like a null or an undefined here, and it wouldn't play anything. But
And it doesn't change the length of the. Oh no, we're just okay.
yeah,
The sequence is just length.
yeah, so it does change the length of the sequence, but sequence.length will always be whatever this length is. So if we add notes to it, this code will still work. But I'm actually going to talk a little bit more about that on Wednesday when we talk about rhythm. So let's see. So now let's visualize what note we're playing so we can kind of see what's happening. So I'm going to go to my draw function for a second and add some visuals in here. And I'm going to use something kind of similar to what I used here. Whoops, I'm going to display different things depending on the state of the transport. So I'm going to say if transport dot, oh, I got to start with tone, tone dot transport dot state equals stopped. Let's tell the user to click. So we'll say text click here to start. And let's put that in the middle of our canvas, width over 2, height over 2. And otherwise, if tone.transport.state equals started, then let's display the current note. But we need to know what the current note is. So in here, we get this note, but this only exists inside of play loop. So we need another variable to set to our note. So let's say let display note, and it's gonna start at C4. So let's just initialize it as C4. Um, and then whatever note is currently being played, so right here, we can just set that to the display note. So we can say display note equals note. That way we know that whatever we're seeing on the screen will be synced with what's happening inside of our loop. So let's go back here. And so if we're playing a note, let's do text display note, and we'll put that in the middle of the canvas as well, width over 2, height over 2. And now we should be able to see the note. Oh, the text is kind of small. Let's set up our text design. So let's say text align, center, center, and text size. Let's do like, I don't know, 30, something like that. Okay, and let's see. Cool. So now we get to see the notes that are being played as they're going. And so that's nice. And again, we have this separation between our visuals and our actual sound. So our play loop is doing everything in terms of creating the sound, but we're using that loop to let our visuals know what they should be displaying. So they need to talk to each other, but they're not working at the same time because that will kind of screw up how the computer works with things. Um, Okay, so we're just gonna do a couple more things, but we're almost done with what I want to do here. Um, so yeah, as we saw, we can add notes here very easily. So if I add another note, let's say instead of going back to C4, I want to go down the arpeggio. So I could go G4, E4 at the end, and let's see how that sounds. So that's kind of fun. But what if we wanted a sequence that was randomized? We are going to talk about this more when we do some generative music. But we've already kind of done this. I think in a previous lesson, we made like a random note function. So let's do that again, just so we can get a little bit more interesting output from this before we get into more generative stuff. So I'm actually just going to get rid of everything in this sequence. And I'm going to make a new bit of code that will create a random note for me. And to create a random note, I'm going to stick with MIDI for now. You could just use random numbers, as we saw last week. Francis was asking about playing notes outside of the scale, and we can just play random numbers, and it will play the frequency of that number. And it probably will sound kind of cool, but it won't sound like Western temperament, which is what MIDI is based on. So let's just add some notes in here. So our basic notes are, let's say let notes, and let's make a list of the notes that we want to use. And we'll start at C, because that's usually where we start in music, even though obviously in the alphabet A comes before C. But we'll say C, D, E, F, and G, and then go back to A and B. So those are all of our basic notes. And then we also have different octaves in MIDI. So our octaves go from 0 up to, I think, 7 or 8 or something. But 7 and 8 are probably too high. Let's just go to 6, I think will be good. And we probably don't need 0 either. It's probably too low to really hear. So let's go 1 through 6 for our octaves. And so now let's make a function that just sticks these two of these things together and gives us a note back. So we'll make a new function called getRandomNote. And another nice thing about P5 is that there's all these built-in random functions, so we don't have to write like our own randomizer. So we can just say let note, or actually we can use a constant here. Constant note is random of notes. Okay, so this is going to give us a random value from our list of notes. So that could be C, D, E, F, G, A, or B. It's just going to give us one of these strings. And then let's just add a number on there. So we can say plus random octaves. Uh, and so this is going to be really all over the place because we're playing like the whole range of our C major scale. But that's okay. We'll just listen and see how it sounds. And so once we create that, we'll just return it to wherever we call the function. So we'll create this note, and then when we say return, it's going to take the value of that note and put it wherever we call this function. So now let's make our sequence random. So let's go to setup, and so we have this sequence with nothing in it. And so after we set everything up, let's generate our sequence. So we can decide how many notes we want in our sequence. So we're going to use a for loop for this. Um, Hopefully you guys remember for loops from MMP 210. I think we've talked about a little bit, but I'll go over it again if not. So we're going to add some random notes to our sequence. So we're going to add a for loop, start counting at 0. So for let I equal 0. And then we just need a number of notes. I'm going to do 16 just so we have 4 bars. So I'll say I is less than 16 and then I plus plus. So remember with our for loop, we start with a condition where we want to start counting. And almost all the time, like you'll see this a lot, it's always going to be I equals 0. Sometimes it might be like X equals 0 or I equals 1 or I equals some larger number and we count backwards, but a lot of the time it's just I equals 0. We're going to start counting at 0, and we're going to count up to the point where I is still less than 16. So as long as I is less than 16, we're going to keep going. And then we count by 1. So each time we go through our loop, we just add 1 to I. And so eventually I will be 16 and we'll stop looping. So for each loop, I just want to add a random note to our sequence. So I'm going to get a note. I'm going to say constant note. I spelled constant wrong. Note equals get random note. And so what this is going to do is run this function. It's going to create a note down here, and then it's going to return this note back to me inside my loop. So I'm going to get a random note, and then I'm going to take my sequence and say push the note. And you could also just throw get random note directly in here. You don't really need to do it this way, but this is a little bit more clean to read. Um, so let's print out our sequence and then we can play it and see how it sounds. So I'm going to console.log our sequence. And so there's our sequence down here. You can see D1, F1, A5, da, 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 and every time we run this, it's going to be different. So if I reload this, now it's something different. So we're already kind of creating generative music because we have a different sequence every time. So let's listen to this sequence. So it does sound quite random, but that's okay. We'll do some more interesting stuff later. One way that you could change this to make it sound less random, first of all, some of these notes are still too high. So let's take out 5 and 6. Let's just do 1, 2, 3, 4 on our octaves. But you could also restrict the number of notes that you play. So right now I have all of the notes in the C major scale, but you could take some out. Like you could say I only want three, uh, 3, 5, and 7. So those are like the sort of main notes in a major chord. So I could take out D, take out F, and take out A. And this will give me something that sounds a little bit different. So that's kind of cool. I could also change the chord itself. So I'll go over this more next week when we talk about harmony. But if I just play, major notes or notes from the major scale, it's always going to sound, like a major note. So if I wanted to have a minor thing going on, I could change this E to a D sharp. I could change this B to an A sharp. Then that would give me a minor 7 chord in C. Um, so we could see how that sounds. So it gives you a little bit of a different quality. But for for people who don't know a lot of music theory, which is probably most of us, we'll go over a much easier way to generate different chords and scales next week. Let's speed this up a little bit so we can hear it better. I'm going to change the quarter note to an eighth note again, and then let's see how it sounds. So that's kind of cool. I think maybe take out the 1 on the octaves and put 5 back in. I think that'll be a better range. And notice also the length of the sequence. Since I have 16 notes, it doesn't really sound very repetitive, but at a certain point you realize it's playing the same thing over and over again. But listen if it's just 4 notes. It'll become repetitive very quickly. Those are a little too high. Let's go back to, let's just do 2, 3, and 4. So you can hear how repetitive it is pretty quickly. If we do 8 notes in our sequence, we'll probably be able to hear the repetition, but it'll be a little less repetitive. If we go up to 16, then we'll start, we'll hear the repetition, but it'll be a little less clear. If we go up to 32, and you don't have to, double it each time, I'm just doing that, but if we go up to 32, it's going to be hard to hear where it repeats. So yeah, I don't really know where that one started to repeat. So depending on what you're going for with your program, doing more or less repetitive sequences might make sense. And you could have you can also play multiple different sequences at the same time. So you can start to layer things on top of each other, which is another thing we can look at next week once we finish these basics. So I'm going to set this back to 8 just so we can kind of hear that in the example. And I think that's everything I want to cover. Are there any questions before we go to just workshop time for if you guys want to see stuff on here or change stuff on here before we move to working on our own things?
I have something to say.
Okay.
I finished the Tone.js assignment, the first part, and I
Okay.
could show you it
Um,
right now.
Yeah, let's do that in a second. So let's see if there's other questions first. Does anybody else have questions or? Okay. So let me stop recording.